Hello, Algebra 2. Today we're going to go through Edgenuity Section 9.5, Transformations of Functions. We've got two objectives to this. Identify a function as belonging to a family of functions and analyze a function rule or graph to determine the transformations of the parent function. And we're going to be really focused on parent functions and how they change. So let's talk about sketching each of these parent functions. We could do this with technology, but we can do it without technology too. As a general rule, if you want to make a table of values, let's say we're doing it for this first function, y equals x cubed, okay? As a good sort of general rule to start with, if you start with these 5 values and then adjust from there depending on how the math works out, usually you get a decent picture of the graph. So if you start with -2, -1, 0, 1, and 2 as your choices for x, remember you get to choose x. That's why it's called the independent variable. The independent variable is the variable or variables that are inside the main expression. The dependent variable is always the answer. And so for y equals x cubed, if I plug in -2 for x, that's -2 cubed, which is -2 times -2 times -2. So -2 times -2 is +4, and +4 times -2 is -8. If I plug in -1, that's -1 times -1 times -1, which, if you do that math, comes out to -1. That's -1 times -1 is +1, times another -1 is -1. 0 cubed is 0. 1 cubed is 1 times 1 times 1, which is 1. And 2 cubed is 2 times 2 times 2, which is 4 times 2, which is +8. And then you graph those and look and see, do I need anything else to give myself a better picture? So let's go 1, 2, 3, 4, 5, 6, 7, 8. 1, 3, 4, 5, 6, 7, 8. And this is just a sketch, remember. I'm just trying to get an idea of the basic structure of these parent functions. Parent functions are the most basic version of the function, and then we're going to modify those. You're going to see how that happens. So we've got -2, 8, which is somewhere down here. -1, 1, which is here. 0, which is here. 1, 1, which is here. And 2, 8, which is here. And connect those with a smooth curve. And you can see it does something like that. Remember, this is just a sketch. But that's what y equals x cubed tends to look like. And so I can give sort of a tiny version of that here. Remember, we just want the basic shape. We want to know basically what it does. Okay? So there's y equals x cubed. And let's do another table. Now you could be using Desmos to look at these, and that would be perfectly okay. But I'm a bit old school, and knowing how to build tables, that skill actually turns out to be a pretty important skill. So let's try with this y equals the square root of x. Okay? -2, -1, 0, 1, 2. And I always leave some room at the bottom of these tables just in case I should have some more. So if I try and put in -2 right there, one of the things you might notice immediately is that -2 doesn't work. right? It just plain old does not work. So, well, not that it doesn't work. Let me be a little more clear. It doesn't produce a real answer, and that's all we can graph on the Cartesian coordinate system is real answers. So this would give me, doing square root of -2 would give me an imaginary answer, and that doesn't help me. So there's no point in doing the negatives. They give me imaginary answers, which I can't graph anyways. It's good to know that they do that, but it's not worth me going through the process at this point. So square root of 0 is 0. Remember, the square root asks you a question. It asks you, what number did I square to get the number inside the square root? So square root of 1, well, 1 squared is 1, so I squared 1 to get 1. Square root of 2, now, if you do that into a calculator, you'll see it comes out with some really ugly decimal. So I'm just going to leave it as a square root of 2. Now, when you look at that, there's 2 good points to graph, but we'd like to have more than that. So you want to start picking smarter values, like 4, for example, because the square root of 4, what number did I square to get 4? Well, 2 squared is 4, so I squared 2. And then maybe 9, because the square root of 9, what number did I square to get 9? 3 squared gives me 9. And that gives me some better points, right? So we got to go out to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We got to go up to at least 3. So let's go up to 5. You'll notice there's no negatives involved here. I could put in some negative ones, and we should probably talk about that, but we've got 1 at 0, 0, 1 at 1, 1, 1 at 2 square root of 2, which is a little less than 1.5 if you want to look at it, but more importantly, 4, 2 about there, and 9, 3 about there. So if you connect them with a curve, with a smooth curve, you'll see that it will keep going up, but very, very slowly. And of course, what happens if I start putting in negative numbers? If, for example, let's say up here, since I don't need the negatives, if I were to put in, I can't put in negative numbers and get real answers. So what could I do instead? I could look at like 1, or not negative 1/4, sorry, 1/4. And the square root of 1/4, it turns out, is 1/2, so you sort of see that in there. And so this is the full thing, and we've got this like end point here, and that's just how square root functions are. They just start from there and curve up a little bit at a time. So that is the parent square root function. And usually when I talk about parent functions, I like to use p of x. So I'm using y equals because that's what Edgenuity used, but usually I'd say like p of x equals, say, 1 over x, the next one we're going to do. Okay? So let's, again, make ourselves a table for the parent function, p of x equals 1 over x, or y equals 1 over x. And now let's start plugging in numbers, and let's start with the same numbers, but I'm gonna leave some space here. So we'll do -2, -1, 0, 1, and 2. And it's pretty easy to see. You'll get -1/2, -1, and then undefined right here. You'd have 1/0 here. And we're going to have to talk about what happens around that point. If I put in 1, 1/1 is 1, 1/2 is 1/2, 1/2, and then let's explore what happens there. Let's talk about -1/2. What would happen if I did 1/(-1/2? That is, I'm plugging in -1/2 for x. Well, division, that division right there, is really defined as multiplication by reciprocal, right? So you can use the mnemonic, the mental algorithm, keep, change, flip. To do this, you keep the top, change to multiplication, and flip the bottom, which is just 1 times -2, because -2/1 is just -2, and 1 times -2 is -2, right? So this one gives us -2. If I put in +1/2, I'm running out of room here, so I have to squeeze this in. But if I put in +1/2, I would pretty similarly, everything would come out the same except for this would be positive, this would be positive, this would be positive, so this would be positive. So I'd get a +2. So let's look at how that graphs, and if we need to expand the table even more to look at this, right? So let's make our numbers a little bit farther apart, change our scale a little bit so that we can look at this a little bit better, because now we're dealing with halves and stuff like that. So -2, -1/2 is there, -1/1 is there. We've got -1/2 and -2 there. I'm taking that from that right there. So we're sort of seeing something there. And then 1/2 and 2 is like there. 1 is there, and 2 and 1/2 is there. So we're seeing that same sort of, if we connect this with a smooth curve, we connect this with a smooth curve, and then if you think about what happens as the negative numbers start looking larger, that is, if we take -4, -5, -6, -7, and so on, we start to get closer and closer and closer to that. But notice we can't make, there's nothing I can do to create a y value of 0. And at the same time, as I get closer to 0, I'll be dividing by fractions with larger and larger denominators, which means I'm multiplying by those denominators. If I divide by 1/3 or -1/3, I'm going to get I'm going to do 1 times the reciprocal, right? That's what division is. It's multiplication by reciprocal. So every time I divide by a fraction, by a 1/over fraction, I'm actually multiplying by the denominator. So if I divide by 1/3, I'm actually multiplying by 3. If I divide by 1/5, I'm multiplying by 5. So as I divide by -1/over fractions, I get larger and larger looking negative numbers. As I divide by +1/over fractions, you get larger and larger positive numbers. Same thing here, as I keep going along this line, I get 1/overs and close to 0, but I'll never get 0. And so this winds up looking like that, and then you have this imaginary line that goes up and down in between these two there, and then horizontally there as well, and we call these asymptotes. This would be a vertical asymptote, and this one would be a horizontal asymptote. Asymptote. Strange looking word, right? And these asymptotes, you can't cross them, you can't touch them, but you can come infinitely close to them. So that they're this weird sort of line, but they're pretty important. And this is just what y equals 1/x, that parent function, looks like. So let me get rid of this, and then we'll sketch a small version of that parent function. There are a lot more parent functions, and you're going to run into them as you go through this lesson. Some of them you can do, a lot of them you can do with a table, like these ones. So I need asymptote there, and I follow the asymptotes, and I follow the asymptotes. When you think of asymptotes, if you've ever seen the game Asteroids, Asteroids kind of works like it's on this weird asymptote where if you take the ship and you take it down to the bottom of the screen, all of a sudden it magically appears at the top of the screen. These asymptotes do the same thing. You follow it down seemingly forever on this side over here, and then after forever it magically goes to positive infinity, jumps over that line, and starts coming down. It's a strange phenomenon, but that's just how it is. If you build the table, this is what happens. Okay? So those are some of our parent functions. We have others. You can do the parent function x squared, p of x equals x squared, which looks approximately like that. There's a parent function absolute value of x, which looks like that. As long as it's the basic version, there's a parent function for almost any, like, they call them families, that's why they use the word parent, but every big group of functions. So it says sketch each using transformations. So let's look at these problems here, and let's start with A. And what I want to do is remind you that the parent function for these square root functions is p of x equals square root of x, and it looks kind of like that. Okay? It's got that little curve to it. It rises slowly, and it's got that endpoint. So what we're going to do is we're going to talk about how you can look at a modified version of the parent function and know exactly how to sketch it out. Okay? So the basic rules look like this. I'll write them down here, and then we'll have them. If you add or subtract, really subtraction is a form of addition, so add or subtract. If you add or subtract grouped with x, like this, like this, like this. Grouping may be symbolized by putting it in with the symbol. It may be symbolized by having parentheses around the x in that thing. Lots of ways to show grouping. Okay. If you add or subtract grouped with x, then there is a shift in the x direction opposite of what you see. Okay? If you add or subtract not grouped with x, then the shift is in the y direction as expected. So these are two really good rules to follow, and they're really going to help us a ton in this, okay? So this is the parent function, and these are how shifting, that is transformations, which only occur with addition and subtraction. This is how they shift that parent function. So for A, for example, let's talk about what the shifts are first. We've got a shift in the x direction that is grouped with x. So there is a shift in the x direction of, and then it's opposite of what you see. So I see a -1, so the shift in the x direction is going to be of +1. That is, I'm going to move everything about this function +1 in the x direction, that meaning left and right, right? And then if I look not grouped with x, over here, that's how the y direction shifts. And there's one of those as well. So I shift in the y direction, and that is a shift exactly as you see it. So it is of +3 in the y direction. So what that tells me is that I'm going to move right by 1. I'm going to move everything about this graph right by 1 and up by 3, right? Because the x direction is left and right, and the positive x direction is right, and the y direction is up and down, and the positive y direction is up. And I almost never talk about whether we're going left and right or up and down. I talk about whether we're moving in the positive or negative direction for each, because that's how those graphs exist. And sometimes it's a lot easier to talk like that. So, and most people don't, right? So I'm trying to get you used to talking like that. I don't want to go back to the, are we talking left or right or up or down? It's not as helpful. as if I get you used to talking about positive x and negative y and things of that nature. So we need to shift 1 in the x direction and 3 in the y direction, and that means we'll start there instead of starting here. And other than that, there's nothing else. There's only the addition and subtraction modifying this. So there's nothing else that has to happen, which means it moves and then it looks exactly the same as the parent function, just moved. So I just re-sketch that parent function. And that's A, and I'll give you a moment to look at that before we move on and tackle B. So I'm going to erase the stuff for A now. And we will talk about B. And again, there's shifting, we're adding, subtracting. There's a shift in the x direction that we can talk about. That's grouped in with x here. It is opposite of what you see, so it would be a shift in the x direction of -1 because we see +1 right there. And then we have a shift in the y direction of, as you see it, so of +3, and that lets me sketch it again, right? So now I need to be at -1 in the x direction, +3 in the y direction, and other than that, it looks exactly the same as the parent function. So there's another one. I'll give you a moment to look at that and ponder that one. All right, so now I will erase B, and we can look at C. And this is going to be the same process, right? I'm going to look at the shifting. That's all there is shifting or translations. There is a shift in the x direction, opposite of what I see grouped with x, so that's a shift in the x direction of +1, and then a shift in the y direction, not grouped with x, as I see it, so a shift in the y direction of -3, and so I need +1 in the x direction and -3 in the y direction, which means it starts there and looks like the parent function. So I'll give you a moment to look at that. And now let's move on to our next question. All right, so this time I'm going to give you a description, and we're going to try and write the equation from the description. So write the equation and graph f of x equals x cubed translated, and the word translated is the math speak for a shift. Translated left 4 units, that is in the x direction by -4, and down 2 units, that is in the y direction by -2. And then we want to graph it also. So let's remind ourselves of a couple things. It might even be easier. It's totally easier to sketch out first, right? So the parent function is p of x equals x cubed, which, if you go back, looks something like that. And so we're going to modify how that is, right? And the easiest way is take this part here and move it, because it's all shifting, right? So let's sketch it out first, and we'll work on writing it second. But let's sketch it out first. So we're going to take this, move it in the x direction by -4, move it in the y direction by -2. And so let's see, we got to go to -4 in the x direction, -2 in the y direction. That's our new middle. That's our new origin. And other than that, it looks the same. All right. So that's moving that to there. Okay, that to there. And that's all there is to the sketching part. I just picked it up and moved it. It's like grabbing anything that you can like drag and drop. This is dragging and dropping. Okay, that's what shifting, translating is. It's dragging and dropping. You don't change anything about it. You just pick it up and plop it down somewhere else. So now, remember, x direction means grouped with x, right? So grouped with x and opposite. So if it's a shift in the x direction of -4, that would mean I need to do +4. And then I need to make it like the parent function, which means I need to cube that. Okay, and then the y direction is not grouped with x and exactly as you see it, so that's going to have a -2 there, and let's give it a new name. They're calling this one f of x, so let's call this one, this modified one, g of x, and there is our new function that has been translated or shifted. I'll give you a moment to look at that. And let's move on to the next question. All right, describe the transformations in f of x equals x plus 1, the square root of x plus 1, and then 5 less than that, and sketch the graph. So let's talk about the transformations. It's all addition and subtraction, so there's only shifting or translating. Shifts are called translations in transformation speak. But so let's talk about the shifts. Is there a shift in the x direction? Is there any adding or subtracting grouped in with x? Certainly there is. It's right there. So if there's a shift in the x direction, you look at what it is, and you write down the opposite of what is grouped in with x. So I'm doing +1, so there's a shift in the x direction of -1. And then shifts in the y direction are not grouped with x. That's that part over here. So there is indeed a shift in the y direction. And it is exactly as you see it, so there's a shift in the y direction of -5. And we got to remember what the parent function looks like for this. The parent function is just the simplest version of that function, which is p of x equals square root of x. And remember that that kind of looks like this. So for our new function, we are shifting that -1 in the x direction, -5 in the y direction, so that endpoint, this right here, has moved to here, -1 in the x direction and -5 in the y direction. But other than that, it looks exactly the same. So I'll give you a moment to look at that. All right, let's move on. All right, if f of x is the original graph, describe the transformation to g of x. So here's, this is a modified version of the parent function already, but what's the big difference between this one and this one is what we're asking. And this one has flipped, okay? So we've got, let's say, from f of x to g of x, there is a flip in what direction? In the y direction, right? It's gone from pointing up to pointing down, so we flipped it. We've flipped up and down. We've swapped up and down. So that's the y direction. Anything that goes on in the y direction transformations are not grouped with x. Okay? And that goes for this also. And flips are created by putting a negative out front. So, and that'll mean two different things. If you're grouped in with x, you have to put it like next to the grouping, right? If you're not grouped with x, you put it outside the whole thing. So, so we've flipped. One of the ways of describing that, the way that Edgenuity wants you to describe it in this one, is that we have, they don't want you to use the word flip. Okay, they want you to use the transformation term, which is reflect. So, reflected over the x-axis. And I'm not a huge fan of this terminology because it can be confusing. You can confuse, because you see x-axis, you can confuse it with the x direction and think you're going the other way. And I like saying it's been flipped in the y direction. That's much clearer. But anyway, so there's that. Now, there's also a way of describing this purely with symbols, which is that g of x, the way we could describe g of x is that it is negative, the negative of f of x. So if we put a negative out in front, not grouped with x, then that would happen, that flip would happen. So that's another way to think of it and describe it, and that's a really important one because it tells you how to write equations, right? All right, so I'll let you look at that for a moment. And let's move on to the next problem. All right, describe the transformations to go from f of x to g of x. All right, well, what do you see? Let's just list them. We've got a flip in the y direction. Certainly, we go from pointing up to pointing down. The only way to do that is a flip in the y direction. So remember, that means the proper, I guess, way to say that is reflect over the x-axis, or a reflection over the x-axis. So that's one thing that's happened. A second thing that's happened is clearly it's been shifted in the x direction, right? There's been a shift in the x direction, and we haven't really marked anything, so we don't know how far, but if there were good markings, we could count it. I don't know, let's say that vertex, this part right here, let's say that has moved, I don't know what, 3. So a shift in the x direction of +3, which would be the sort of more proper way to say it would be a translation in the x direction of +3. And then the third thing that's happening is that, do we have a shift in the y direction? Well, think of if I took this and just flipped it over, I'd be up at the same height, and I kind of look like I'm up at that height. So I don't think there's any shift in the y direction. But look at this one compared to this one. One of them is clearly skinnier than the other one, right? So that's the third element of these ideas, which is that there has been a shrink. We talk in terms of shrinking and stretching. A shrink in the x direction. And we have to talk about how much that shrink is. Shrink in the x direction by a factor of, let's say, 1/2. We really don't know exactly because it's really hard to tell that specific thing. But shrinking and stretching, if you see it, you're going to have to make a table if you're trying to graph it, unless you just sort of sketch it comparatively with the parent function. But anyways, the way to say that is that there has been a dilation in the x direction by a factor of 1/2. Okay, so a flip, remember, that is, what that means is put a negative out front in this case because it's in the y direction. A shift means adding or subtracting that number, and since we're grouped with x, we want to group with x, and when you group with x, it's the opposite of what you see, so we want to subtract 3. And then same thing here. We want to shrink in the x direction, so we want to group with x. Oops. Group with x. And again, it's the opposite, but when stretching and shrinking happens, it happens by multiplication. So we want to see this as multiply by the opposite, and in multiplication, the opposite means the reciprocal, so we want to multiply by 2, okay? So now we can actually figure out how we would have to modify f of x to go to g of x, okay? So this g of x, if I apply all the modifications that I've got written down to f of x, it'll tell me how to do this. So first of all, put a negative out front of it, okay? And then it's f of, and then I've got this multiplication of 2, and then I've got this subtraction of 3, like that. And that's how it modifies, okay? And so whatever the parent function, whatever this one is, these are all the changes that I had to make to it. I had to put a negative out front to make the flip in the y direction. I had to subtract 3 grouped with x to shift it positive 3 in the y direction. And I had to multiply grouped with x, like that, in order to shrink it by a factor of 1/2. Okay, so I'm shrinking it down by doing that. All right, I'll give you a moment to look at that. There's a lot there to digest. And notice that I didn't try and figure out what the actual equations were. I just took the f of x and applied the modifications, and you can totally do that in these general cases. All right, let's look at our next problem, which is a vertical stretch of f of x equals x squared. So vertical, meaning the y direction. So in the y direction, we're not going to be grouped with x, and we're going to be doing exactly as we see. So let's talk about what each of these, let me just erase this all together. Let's talk about what each of these does. So y equals 4x squared. This is multiplication. Now, is that multiplication grouped with x? Because that's going to be important. Well, there's an easy way to tell with these that it's not, and it's by looking at this one. In contrast, this multiplication is grouped with x, right? Whereas this one, the one that we're looking at, then would not be, because for it to be grouped with x, it would have to look like that instead. And clearly, it doesn't look like that. So it's all about whether or not you've got these parentheses grouping and this thing on the outside. So multiplication by 4, not grouped with x. So what does that tell us? That tells us that we're not grouped with x. So first of all, the multiplication tells us a stretch or a shrink. So it's one of those. Not grouped with X tells us whatever is going to happen in the Y direction, and happening in the Y direction tells us whatever it is as we see it. Okay, acts as we expect it to act. So, with all of that information, 4, which is a number bigger than 1, which is when you would expect a stretch, and Y direction tells us it is a stretch, by a factor of 4 in the Y direction. So, vertical, meaning in the Y direction, meaning up and down. We've got a stretch, so A should be our answer. But let's explore what these other ones would do. Okay, so first of all, in this one, what have we even got there? Well, we've got addition, which is a shift, a translation, not a stretch. Multiplication is what causes stretching and shrinking. There is no multiplication here. It's the two things being added together. So this one you can completely ignore. Same thing with this one, there's subtraction. That means a shift. Adding and subtracting means shifts. So I can completely ignore that one. So the only other one to look at is that one, because indeed there's multiplication here, but that multiplication is grouped in with the X, meaning it's not vertical, it's horizontal. It's in the X direction, right? So that one doesn't do it either, so it's got to be A. So it's got to be that one. Okay? I'll give you a moment to look at that, ponder that. Let's move on to our next question, which is a horizontal stretch. Horizontal. What does that mean? That means X direction. So now we're looking, since we're looking in the X direction and we're looking for a stretch, we're looking to be multiplied. We're looking for multiplication, and we're looking for it to be grouped with X. And since we're looking for a stretch, that means we're actually looking for a number between 0 and 1, because when you're doing things in the X direction, when you're grouped with X, things happen the opposite of what you would expect them to happen. So small numbers will give me, small multiplications will give me stretches. Large multiplications will give me shrinks in the X direction. Okay? Well, let's look. This, not grouped with X, right? This, not grouped with X. This, addition. It's not a stretch or a shrink at all. This one, grouped with X, a number smaller than 1, which would make me expect a shrink, and then every time you're grouped with X, whatever's happening in the X direction is the opposite of that. So we're grouped with X, which means the X direction. We're multiplying, which means we got a stretch or a shrink, and it looks like there should be a shrink, but there really should be a stretch because things happen the opposite of what you expect them in the X direction. So D winds up being our answer. I'll give you a moment to look at that and ponder that. And let's move on to our next question. How was the parent function f of x, or I always like putting p of x, but f of x is what Edgenuity uses. How was the parent function f of x equals absolute value of x changed? Well, let's take a look at that parent function. Let's sketch it out. That parent function turns out is at 45-degree angles and points up. It's at the center. So a couple of things have changed, right? If you look, if I sort of, there's 45 degrees, there's 45 degrees. So two things have very clearly happened. We have had a flip in the y direction, which again would mean a reflection over the x-axis. But I prefer the wordage that we have flipped in the y direction, because it says how we're going to modify everything. And then there has been a shrink in the x direction. So what does that all mean? Well, that means that I'm going to take this absolute value of x, and a shrink in the x direction means I am multiplying grouped in with x. So, and a shrink, you would expect a fractional number, so it's got to be the opposite of that. It's got to be a number bigger than 1, and if I'm shrinking, let's say, by a factor of 1/2, then that would mean using the reciprocal of that, 2. It might be by a factor of 3, it might be by a factor of 4, it doesn't matter. I would just put in those numbers. And then the flip in the y direction would mean a negative not grouped with x. So that would be our new one if we call it g of x. That's how we would write g of x, with maybe a 3 there, or a 4 there, or a 2.5. It's really hard to tell. But that is how that parent function has changed, and that's how the change affects the equation. Okay? I'll give you a moment to look at that, ponder that, and then we've got one question left. Let's look at our last question. Sketch each of the graphs. All right. So these are all different versions of the parent function p of x equals square root of x. Okay? And again, if you give yourself a little sketch of the parent function, then you can start figuring out the modifications, and things happen quickly and efficiently from there. So let's look at A. What sort of shifting do we have? Do we have any stretching? Do we have any flipping? All that kind of stuff. Well, there's no negatives like being put in the front of anything, so there's no flipping. There's no multiplication, so there's no stretching or shrinking. There is subtraction, which is a form of addition. So there is a shift. That shift is grouped in with the x. That subtraction is grouped in with the x. So it's a shift in the x direction, and it's a shift in the x direction of the opposite of what we see, so of positive 4. Other than that, there are no modifications to this, so the change for A just looks like moving it over to 4 there in the x-axis and redrawing it. And that's it. I'll give you just a moment to look at that, and then we'll do the next one. I'll have to erase this. Okay, so let's look at B now. And let's see what happens with B. Here again, no negatives, no multiplication, so no flipping, no stretching or shrinking. But we do have adding 4 grouped in with the x, so there's a shift because we've added. It's grouped in with x, so it's in the x direction. So see that it's right there inside of the square root. And then it's plus 4, and x direction is the opposite of what you expect. So we get minus 4. So for B, again, only one shift, and we do it in the x direction. And other than that, it looks like the parent function. Okay, I'll give you a moment to look at that one. All right, let me erase this and we'll look at C. C and D are going to be a little more difficult to visualize. Okay, so let's talk about C. First of all, there is multiplication, right? So we have a shrink or a stretch. And to know which one, first of all, we got to know which direction. So that is not grouped in with x, so that's going to be in the y direction. And in the y direction, things happen as you expect. This is a number bigger than 1, so it's going to be a stretch. Okay? So this is a stretch in the y direction by a factor of 2. Meaning, imagine grabbing onto this thing and stretching it vertically. Okay? If you had something that could stay there but was sort of elastic and you stretched it up and down, what would it look like? That's what we're gonna. That's where the visual challenge is going to be. And then that's not all we have. We have grouped in with the x a plus 4, which means we've still got a shift. This in the x direction, opposite of what we see, so of negative 4. So those are the 2 things now that have to happen. And the reason this is difficult to visualize is because, okay, so we can do the shift in the x direction easily. Just shifts by negative 4. So it's endpoint shifts. That doesn't change anything. But now, if I stretch it vertically by a factor of 2, imagine taking that and stretching it up, which means it's got to climb higher, faster, and go up faster in general, twice as fast, right? So that's an approximation to it, versus if it didn't have that, it might look like this. So that's the only good way to do the stretching is to compare it to the original one. Okay, and that can be difficult to do. That's why I say a lot of times you either have to have that comparison there, or you have to make yourself a table to really get some points that will help you. All right, take a moment to look at that. And let's get rid of these and look at D. Talk about what happens at D. Again, you might see that we've got a stretch or shrink. That is a dilation. So for D, we've got a stretch or shrink right here. Multiplication is what gives you stretching and shrinking. This time, it's grouped inside with the x. So this is in the x direction. Things happen the opposite of what you expect in the x direction. It looks like this would be a stretch. So in reality, it's a shrink, okay, of 1/2 in the x direction. So imagine then that we take this and we squish it down like an accordion, and what would happen then? Okay, that's what we're looking at. Notice we also have a shift, and that shift is still in the x direction, opposite of what I see. So I see +4, so it'd be -4. So when I'm sketching D, I go -4 in the x direction, and then if I took this and squeezed it down, it would rise higher faster, kind of like that, as compared to the original one, which would do that, right? So I'll give you a moment to look at that. And that is our final problem. Thank you so much for listening.